This tutorial will walk through the creation of a simple points-based project from beginning to end. We select the photos to use in the project. After hitting Next, we see Photomodeler has found a matching calibrated camera. This camera was used during the procedure outlined in the calibration tutorials. If a matching camera was not found, you will be prompted and can load a camera calibration from an existing project. We double-click to open Photo 1, switch to Line Mode, and click to outline the box. Line Mode can be used to create lines between existing points, or in this case, we create points and lines at the same time. We are doing an approximate project, so the placement of the marks is not critical, and we can refine them later if we want. Now we open the second photo, which is taken from the front left of the box. Switch to referencing mode. We activate Photo 1 and select all points on the photo. The selection causes Photo 1 to become the referencing source. The blue box around the edge indicates that this is now the source. We move over Photo 2 and click on the location corresponding to the point highlighted in yellow. To help locate the source point, a rubber band line is also drawn between the cursor and the yellow reference source point. As we click, a mark is created and referenced to the point in Photo 1. After each click, the highlight automatically advances to the next point. If we were more concerned about accuracy, we could zoom in to create these marks at a more precise location. The minimum number of references has now been met, and automatic processing has run, solving the camera positions for Photo 1 and 2. Both solved camera positions are indicated by the cameras on the thumbnails here, and the title bar of the photo. We can now open a 3D view to see what has been solved. If we turn on camera stations, you can see where their positions have solved. Everything looks good, so we continue adding points, references, and photos. We open the third photo, which is of the back of the box, and reference the points from Photo 1. This point cannot be seen on this photo, so press the Escape key to advance to the next point. The project now has sufficient information to orient Photo 3. As the photo is now oriented, when we go to mark this next point, we see reference helper lines. This point is already marked on two other photos, so we have two lines. If the project is solving correctly, the point's location should be close to the intersection of these lines. See the reference mode tutorial for more information. The next point is marked on only one photo, so we only have one helper line. We mark it here. We have now referenced all the visible points on Photo 1 with Photos 2 and 3. The remaining corner cannot be seen on Photo 1. We click Clear Source Photo. This allows us to select a new photo as the source for referencing. We go over Photo 3. While in Mark Reference mode, clicking on an existing point will select it. Clicking where no point exists yet will create a new one and select it. We click down to create a new point. This selects Photo 3 as the source. We can then reference this point on Photo 2. We open up a 3D view to review the project so far. All corners of the box are now 3D, but we are missing lines to the point we just created during referencing. We use Line Mode to add this segment. See the Line Mode tutorial for more information. We will save this project as wireframe.pmr. This file is included in the tutorial samples if you would like to load the project. Now that we have a basic shape, we will add surfaces. We click on the Path Surface tool. See the Surface Path Mode tutorial for more information. There are other surfacing tools which can be used depending on what the surface shape is and what type of objects are used to define it. See the other surfacing tool tutorials for information on these modes. You can see the surfaces as they are created in the 3D viewer. You can see surfaces and photos if we turn on projections. See the photo projections tutorial for more information. We go to the 3D viewer options, turn off points and lines, and turn off textures. Textures take the existing photos and map them to the model. This gives you a quick preview of the model's textures. You can see how the perspective distortion of the photos causes the textures on the front and top to look warped at some angles. We switch to quality textures. Photomodeler will remap each pixel of the texture, searching for the best image and creating a new texture map. Here we have a quality textured model. You can see the texture distortion has been removed. This quality textured model can be exported in various formats for use with other applications. We will save this project as surfaced.pmr. This file is included with the tutorial samples. If our focus had been measurement rather than visualization, we would need to check our project quality and verify our mark placement. One thing we can monitor easily is a project's residual. The residual is the number of pixels the marked point's location differs from its projected 3D location. The largest residual in the project is displayed on the status bar. The lower this number, the better. Clicking the status bar will open the photo and select the point with the largest residual. We can zoom in and see its mark location is not very well placed. We can drag the mark to the correct location to improve the project. You can review the residuals of all points in your project using a quality point table or using the project review pane and status icon to see metrics that are over defined thresholds. See the point review pane tutorial for more information. After checking the placement of our marks, our largest residual is down to 1.32. The rest of the residuals are also low. We can now add a scale and rotation to our project using the Scale and Rotate wizard. For more information on defining the coordinate system, using a scale and rotate affine transformation, see the Scale, Rotate, and Translate tutorial. We select our units as inches and enter in the known length of 11 inches. Select the line we know to be 11 inches and continue on to adding a rotation. We define the horizontal axis by selecting a point on the left, holding Shift, and selecting a point on the right. Then do the same for the vertical with a point on the bottom and a point on the top. Now we can perform measurements. We open up the measure pane. Select this line. Its length is 3.92 inches. This one is 6.21 inches. The line we defined as the scale is 11 inches. For more information on the measure pane, see the measure tutorial. Because our rotation is defined, when we open up the 3D view, we can specify the view direction. The default is top, but we can also change it to the front. Our scale and rotation definition will also be included if we export the model for use in another package. To export, we select File, Exports, Export Model. Choose the file type, in this case, 3D DXF for use in a CAD package. See the export tutorial for more information. The export is now complete, and the DXF file can be used in a CAD program or other 3D package. This was a brief overview from beginning to end of a simple points-based project. For information and other examples, please refer to the other related tutorials.